Hi, good morning. In this video, we're going to look at our homework from last week, the challenge problem. So if you want to check your answer, this video is for you. Or if you want just some support on how to solve it, because it was a little trickier. So let's skip down to our challenge problem. Now on this problem, we're finding two things: the area and the perimeter of this collection of tiles. Okay, let's do the area first because that's a little more straightforward. So we know that the area of the small tiles is 1 and that the long rectangles is x. So on this first one, I can just write 1 plus 1 because I have 2 unit tiles and I have 3 x tiles. So I can say plus x 3 times. Then for my equivalent expression, I can combine these like terms. So instead of saying x 3 times, I can just write 3 x's because I know repeated addition is multiplication. And then for my unit tiles, I have 1 plus 1 or 2 unit tiles. So that would be a positive 2. And I wrote it in standard notation, which means my x term is first. So 3x plus 2. There are other equivalent expressions using the commutative property, but these are two pretty standard ones. You may have different ones using that commutative property. All right, so next, the little slightly more challenging part, the perimeter. So we know the perimeter is the edge around the outside. The tricky part's going to be right here, but I'm going to do the easy part first. So I have an x side here, a 1 side here, an x side here, 1, 1, 1, 1, x, I don't know what that is, and a 1. Okay, so that green part, that's my easy part. That's based on definition. So now let's look at this like really tricky little part right here. And my guess is that's what held a few of you guys up. Okay, so if I'm looking at this tricky part right here, I want to look at it in relationship to the whole side. Because I know this whole side right here is x. And this purple pink side is a portion of that. So if I subtract away this distance, I'll get the purple distance left. So I know this light blue side right here, because I know these two, that's 1 plus 1. I know this light blue distance is 2. And I know the whole distance is x. So then I know this little sneaky portion right here is going to be x minus 2. It'll be whatever the x is, and remember that's a variable so we can change it, minus the distance of 2. And this may or may not be to scale. Most likely it's not. Most likely it's not to scale. Okay, so then writing my expression, let's see. Writing my expression, I'm going to say I have 1, 2, 3, 4, 5, 6 units. Okay, so I have 6 around the outside. Then let's look at how many x's I have. I have x, x, x. I have 3 x's in my perimeter. So I'm going to say 3x. Then I get to my very strange x plus 2. So this x, or x minus 2, excuse me. So I'm going to add my x minus 2. Excuse me cramming it in here. And then I have a positive 6. So one expression could be 3x plus x minus 2 plus 6. A second expression could be simplifying this. So I have, and I'm adding my x and I'm adding my negative 2. So those signs stay the same. So I have in total 4 x's. And then I have a -2, so plus a -2 plus 6. So I can say 4x plus 4, because I know -2 plus 6 is 4. So that would be another equivalent expression by combining like terms. Now, you may have different equivalent expressions using the commutative property. You may have different equivalent expressions, and that's absolutely fine, but these are two. I hope this video helps. Go ahead and email me or leave me a private comment if you have any more questions.